Morning. This project is actually presented by Group 16 of CyberSafe Foundation for those in cloud security. Before I continue with this project, I first of all want to appreciate the Enugu State Cybersecurity, the SME, and also the CyberSafe Foundation. My gratitude also goes to our tutor, Dr. Mrs. Omotala, and also the coordinator, which is our CS confidence level. I really want to appreciate for giving us the opportunity to learn, to giving us the opportunity to come and impact us. My gratitude goes to them. I also want to use this opportunity to thank my colleagues, those who are in the same group with me. Currently, my name is Onyukunobu. I also have Bonaventure Osita. I have Omoromi Bamikole, Oyodele Omolade, and Queen Sarah Udobong. I want to tell them for the success of this project. Indeed, it hasn't been easy, but with everyone coming together, it was a success. In this project, we achieved what we call team, which is together everyone achieves more. So with the contributions of everybody, the project was a success. So let me just go through it, and in few minutes time, we'll be done. Thank you. All right. The project topic we worked on is what we called application load balancer on EC2 instance using AWS console. Okay, this is the project overview. This project will provide an overview of AWS application load balancer on EC2 instance using AWS console. AWS was chosen because we are more familiar with it. The project will provide a detailed description of AWS application load balancer on EC2 instance using AWS console. We have what we call Elastic Compute Cloud, which is the EC2. EC2 allows users to rent virtual computer on which to run their own computer application. EC2 encourages scalable deployment of application. EC2 provides users with control over the geographical location of instances. EC2 enables various contribution of CPU memory storage and networking capacity for instances, known as instance types. EC2 enables storage volumes for temporary data that deleted when you stop, hibernate, terminate your instance, known as instance store volumes. EC2 provides virtual computing environment known as instances. EC2 provides secure login information for instances using key pairs. EC2 also provides static IPv4 address for dynamic cloud computing known as elastic IP addresses. EC2 provides metadata known as tags that can help and assign to your Amazon EC2 instances. Okay, Elastic Compute Cloud EC2. EC2 provides virtual networks you can create that are logically related from the rest of the AWS cloud and that you can optionally connect to your own network known as Virtual Private Cloud VPCs. EC2 also provides a firewall that enables you to specify the protocol port and source IP range that can reach your instance using security groups. Okay, now let's talk about what we call load balancing, elastic load balancer. All right, load balancing is a technique used to distribute workload uniformly across servers of other compute resources. Elastic load balancer also automatically distributes incoming traffic across multiple targets, such as EC2 instances, containers, and IP addresses in one or more availability zone. EC2 also monitors the health of each registered target and routes traffic only to the healthy targets. It enables selecting the type of load balancer that can suit your network. Now, this is what we call a load balancer. From the screen, you will find out how is you find out the flow of a load balancer. Now let me explain the flow in some few seconds. Now from the user, you can see the user goes direct to the internet, and from the internet it goes direct to the load balancer. So in the load balancer, we will still come about it when we have a target. Here we have three instances here at the database. So the load balancer balances the flow of the traffic that is coming inside the network. Sorry, inside the server. So that's how it works. And this is the database that is also connected to it. But don't worry, in other incoming slides, we'll explain more about it. Okay, we have what we call types of load balancing. First, we have application load balancer ALB, we have gateway load balancer GWLB, we have network load balancer NLB. But don't forget, in this project, we'll be working only with application load balancer as earlier introduced in the introduction. We'll be making use of we'll be talking about only application load balancer. But believe you me, in few other presentation, we'll still touch discuss about the gateway load balancer and network load balancer. Okay, but before then, let me just give a brief definition of what gate load balancer is, because it will give us an edge or an insight to what the application load balancer really means. So gateway load balancer helps you easily deploy, scale, and manage your third-party virtual appliances. It gives you one gateway for distributing traffic across multiple virtual machines, which while scaling them up or down based on demand. That's what like here they say, while scaling them up or down based on demand, based on the resources you want. Here we have the graphical, the image representation of it, but I'm not really gonna talk about it because that is out of scope of what we want to discuss in this project. So we also have what we call network load balancer (NLB). Network load balancer operates at the connection level layer 4. We have different types of layers. For those who are much more good in networking, we have different types of layer. So network load balancer operates at the connection level of layer 4, routing connections to target Amazon EC2 instance, microservices, and containers within Amazon VPC. We have different types of containers. We have all these Docker containers and a lot of more. But that's aside. That one is just, let's forget about it for now. So containers within Amazon VPC based on IP protocol data. The image here represents it, but we're not going to talk about it because we only want to discuss about the application load balancer in this section. All right, now we are in the business of the day today. Now this is what we call the application load balancer ALB. It's using let's just say the functions of application load balancer. It routes traffic to target EC2 instances, containers, IP address, and Lambda functions based on the content of the request. Sorry if I'm using some words here like Lambda and some other things. In this section, maybe in our next this thing, I will talk about the Lambda as well. So even this routing traffic targets and every other thing, Lambda is on its own. It's just a serverless. But let's forget about that for now. So on EC2 application load balancer, this allows a developer to configure routes. We have like kind of route 53, that's a kind of custom domains and all that things to configure and route incoming user traffic to application based in the AWS public cloud. It also operates at the request layer 7. In the other one, we talked about layer 4, but in this place now, we are talking about layer 7. Don't worry, you will still get more. Maybe in the next videos or presentation, we'll talk about networking so that it can give us an edge of what we're talking. So, but for now, just know that application load balancer operates at the request level of layer 7. Okay, this is an image, a graphical representation of how the application load balancer works. From the image so far, you can find out that from the user, for instance, they have 4 instances here running in different availability zones. The first availability zone has 2 instances, the second one has 2 instances. Then the application load balancer, once you are coming inside it, you are not going to the instance, you are going straight to the application load balancer, which already has the targets in the load balancer. So let's just, for instance, if the traffic is much, the application load balancer will balance it. For instance, if there are like 20 persons logging into the website, from this place now you see that we have 4 instances to avoid traffic jam. The application load balancer will balance it, will balance everything so that each instance will occupy, so that there won't be much traffic in one particular instance. And if you find out in this image, we have 2 different availability zones. The essence of this availability zone is for if this one is not working, maybe if there is a failure. Sometimes all this is something connected to the web. If there is a network failure or something like that, the other one will be working. That's why they say that cloud security helps in securing data easily. And another function of cloud is also quick recovery. Even when you lose this, there's an availability zone. So when you are working on EC2 instance, it's best you choose different availability zone so as to avoid failure. So let's just go in and explain more about it. All right, we have what we call components of application load balancer using the AWS management console. Virtual private cloud VPC with at least one public subnet in each of the availability zones used by your target. Configure a target group, register target, test the load balancer. These things are now just a kind of the components of application load balancer, how to create the application load balancer. But just relax, we'll just take it gradually. All right. Right, we have VPCs and subnets. What's actually what VPC? A virtual private cloud, that is what VPC is a virtual network dedicated to your AWS account. It is logically isolated from other virtual networks in the AWS cloud. Specify an IP address range for the VPC, add subnet and gateway and associate security groups. Here these are just a step on how to create the VPCs and the subnets. A subnet is a range of IP addresses in your VPC. You understand? So a subnet is a range of IP addresses in your VPC. Launch AWS resource such as an Amazon EC2 instance into your subnet. Connect a subnet to internet, other VPCs and your own data center, and route traffic to and fro from subnet using route tables. Don't worry, I know I'm using some words, but in due time you get used to it. Okay, now how to create a VPC subnet and other VPC resources. First of all, open the Amazon VPC console, navigation pane, choose your VPC and click on create VPC. Under resource to create, choose VPC and more. Name tag, auto generation. When you see where they wrote name tag auto generation, click the name tag that will be applied to the resource you create. IPv4 CIDR block. Choose an IPv4 CIDR for the VPC. You see another one, IPv6 CIDR block. Choose an IPv6 CIDR for the VPC. Now click on tenancy. In tenancy, you see default dedicated, number of availability zones, custom AZ availability zones, number of public subnets, number of private subnets, customized subnets, CIDR blocks. All right, creating VPC subnets and other VPC resources. These are just the image on it. Okay, create VPC subnet and other VPC resources. Now, when creating it, that's what we call a NAT gateway, a VPC endpoint, DNS options, preview, create VPC. In the DNS options, you see enable DNS hostname and enable DNS resolution. But before I continue, please, if you are using AWS free tier and you don't really want to get debited or pay for it, this NAT gateway is paid for. Yeah. Once you are using NAT gateway, it means you want to pay for it. So if you don't want AWS to debit you or anything, take your money, please forget about NAT gateways. But for more understanding, I advise you go through it again and read it so you can be much clarified on it. All right, now we are in the target group. What's actually what this target group? I've said about it. Select target group, adding instance. Like when I was showing how to create application load balancer, we saw how different instances were working in different availability zone connected to the this thing, connected to the load balancer. Now this target group is when you selected those AWS, those EC2 instances that we're actually working on the target group. That we're actually working on the load balancer. That's the target. Without picking the target groups, nothing will be working in the AWS, nothing will be working in the load balancer. So a target groups allow registration of targets such as EC2 instances. The target group configured in this step is used as a target group in the listener rule when configuring a load balancer. Okay, now these are the steps or sequences on how to configure a target group. First of all, open the Amazon EC2 console. When you open the Amazon EC2 console, navigation pane, under load balancer, choose target group. So when you click on open the Amazon EC2 console, you see where they wrote a load balancer. From there at the down of it, bottom, let's just use bottom of it, you see where they wrote a target group. You choose the target group, then choose create target group. Okay, let me just give basic configuration of it. Choose a target type, the target type, instances, instance ID or IP address, stuff like that. Okay, now this is how to configure the target group basic configuration. Pause and protocol. target types of IP address, choose IPv4 or IPv6. I will explain this later on. Select a virtual private cloud VPC, protocol version. Yes, please, this place is actually, how do I put it? This place you need to be more careful in what you are selecting here. Make sure you select HTTP1 when this request protocol is HTTP1 or HTTP2. Select HTTP2 when the request protocol is HTTP2 or gRPC. Select gRPC when the request protocol is gRPC. Please please, I beg of you, don't make any mistake in this, please. All right, now let's go in. Click on health check section. Advanced health check setting. Choose the health check port count, timeout, interval, specify success codes. Add one or more tags. This one is actually optional. This one is actually optional. Now, register the target. This, oh my God, this is the main part of it. Because without this, nothing like application load balancer without this. Alright, targets must be registered to ensure load balancer routes traffic to them. Register EC2 instance. That's the target we're working on. Steps to register targets. Steps. These are the steps to register the target. Please master these steps very well. It's really important. These are the steps to register a target. Register targets page. First of all, you now select one or more instances. Enter one or more ports and then choose include as pending. See, this include as pending, it really took me much time when I was working on this project, because after registering everything, working on it, I forgot to choose that include as pending, and that was when I was doing the practical before putting it up, right, before putting it down in writing. I was mistaken because I was asking myself, what's the sense of putting it in pending? Something I want to host online, something I want to be working online. Then why would I include it in pending? I had to enter into much more details, making use of my IQ. So please don't forget to include it as pending. IP addresses. Select a network VPC. Yes, select now this select a network VPCs. If you did not choose, please, if you are using AWS free tier and you don't have money to be paying, please select in this place, use default. I beg of you, use default so that they won't credit to use default. Enter IP address using unless you already have a custom VPC for your own, which maybe you pay for it, you are in, then select your custom VPC. But if you don't have, please don't be tempted to create, just use the default. Is provided, AWS provided a default. Enter IP address using instances details. Enter ports for routing traffic to the specified IP addresses. Create target group. Wow. Then click on the create target group. Alright, create application load balancer and listener. Application load balancer must first provide basic configuration information for load balancer, such as a name, scheme, and IP address types. Provide information about network and one or more listeners. Listeners is a process that checks for connection requests. It is configured with a protocol and a port for connection from clients to the load balancer. Wow. Configure load balancer and listener. And then now these are the steps to configure the load balancer and the listener. Now, first of all, open the Amazon EC2 console, navigation pane. Under load balancing, choose load balancer. Also create load balancer. Under application load balancer, choose create basic configuration. These are the basic configuration after you've created on the create this thing. Now, after clicking on create, load balancer name, example my ALB, that's the name of the load balancer you want, example my load balancer, but please there shouldn't be space on it. There shouldn't be space. Scheme, internet facing or internal. Select any of the two. IP address type, dual slack, IPv4, dual slack. Anyone can go. Anyone is okay. Configure load balancer and listener. Now we have what we call network mapping, VPC. Select when you come to the VPC, select the VPC that is used for EC2 instances. Yes, you know when we are creating before you create an instance, I didn't go through how to create an instance because I'm working only on load balancer. Before you create an instance, you select the VPC. If it's a default VPC you are making use of, or the custom VPC you already created. So you select the VPC here in the for EC2 instances. Mapping, select 2 or more availability zones and corresponding subnet. Exactly what I said. They have different availability zone, AZ, A, B, and all these things. Select 2 or more. If you find out I say 2 or more, not 1, I say 2 or more. The essence, I have said it earlier on, the essence is for it maybe when working on it and there's a failure, power failure, earthquake, and in this country, the other one should be working perfectly. That is one of the benefits of cloud than on-premise. All right, let's go in. Listeners and routing, add on service such as AWS Global Accelerator, which is actually optional. Tag, add a task to categorize your load balancer, which is actually optional as well. Create load balancer. Now we are actually going in. Test the load balancer. After now is the time to test the load balancer. It's the time to test the load balancer. After creating the testing it, now after creating your load balancer, you should verify that your EC2 instance passed the initial health check. It's very important. Then check that the load balancer is sending traffic to EC2 instances. Yeah. Okay. To test the load balancer, these are the steps which I have included on how to check the load balancer. After creating it, these are the sequential steps to check if actually the load balancer is working perfectly as you have wanted, as you have expected. Now, after the load balancer is created, choose close it. Navigation pane under load balancing, choose target groups. Select the newly created target group. That is, click on the newly created. Once you click on the target group, it will prompt out another navigation where you now see the newly created one. So click on the newly created target group. Choose targets and verify that your instances are ready. Now, when you click on this thing, now you will see where a page by the right side where you'll be seeing what they call the status check. Yes, status check. That's if the load balancer is ready, you will see it in the status check. But if it's not ready, if it's not, I think that should be 2/2. Yeah, 2/2 or something like that. But you still see it in the navigation page by the right side of it in another page like that. So choose description and copy the DNS name of the load balancer. Now, when you add a load balancer to a website, to your EC2 instance, you cannot be copying you will not be using the EC2 DNS. You understand? You not be the only thing you can now use to remote in is now the load balancer at DNS, because people will now be logging through the load balancer that will balance the incoming traffic or the requests and every other thing. So when you then choose a description, copy DNS name of the load balancer, paste the DNS name into the address field of an internet connected web browser, stuff like that. Just copy the DNS, post it, or even if in that page, in that same page you're working on, you can from as well, that page you're working on, open a new tab in that page, then click on it and run it. If everything is working, the browser displays the default page of your browser. Now, if that the DNS opens the same thing, the same page your EC2 instance open, that means wow, you've done it. 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 That's how to add an application load balancer. In fact, you've done it. So far as it's displaying the same thing the instance is displaying, you are good to go. Now, these are the learning experiences and challenges me and my group encountered during this project. It's really not easy, but first of all, I don't know how to thank our tutor, Dr. Mrs. Omotala. She has really been helpful. In fact, with her help, her advice. In fact, she's not just a tutor, she's just like a mother to us. Wherever you are listening to this, I really appreciate you. Thank you so much, ma, for the encouragement. And also, I cannot forget the Enugu State SME, wow, SA to the governor for giving us Enugu State the opportunity to be in this program. I don't know, without them, this knowledge I've gathered wouldn't be here. Even to our CS Confidence Levy, which is the founder of CyberSafe Foundation, you people are really doing well. I encourage anyone that will watch this video in future, look out for her, thank her on my behalf. She's wonderful. In fact, let me just say she's just a role model to me, because each time I want to do something about it, I'll just go through it and see that she's doing it, then I can do it. The motivation she has been giving me is much more superb than I cannot even think of. Also to my colleagues, my classmates, those in ECSL, Enugu State Cyber Security, my guys, those who have been there, people like Mr. Chinweze, oh my God, he has really been helpful. I also want to thank my manager, Mr. Roland, for the support so far, giving me accommodation, staying there and there. He has really been helpful to me. Also to Mr. Derek, oh my God, he has really been helpful to me. Derek Chinwewe, Ongudiwe, he has really been there. Sheriff, my friend, Pablo, Mankechi, Angela, stuff, people like that. You people have, in fact, everybody in ECSL, you people have really been wonderful to me. They love, and I encourage everybody seeing this. If you are not staying close, reach out to ECSL. That's where you can get all the knowledge you want. So, all right, even to my colleagues that were engaged in this project with Mr. Bonaventure, Udobong, all of them, Bami Kole, the project was a success because you guys were there. I also want to thank my personal mentor. Yeah. I call him my personal mentor, Mr. Achiever. Yeah. He has really been there for us for the success of this project. I really want to thank every one of you. One Michael, my mom, dad, for the support so far. Now let's go into the learning experience and challenges we are encountered. It's an exciting learning experience, though it's really challenging, especially when we are trying to understand the different types of elastic load balancer and the functional components of application load balancer. In this project, we learned about EC2 load balancing, different types of elastic load balancer, and the functionals of each. We also learned on how to create a VPC, and the availability zones involved in including the challenge in the instances. Our biggest challenge was to understand the whole process, the functionalities of each part, each part flows, and mainly some unfamiliar terminology. Seriously, when I was going through it, I was like, oh my God, different unfamiliar terminologies was going through my mind. But then I got to using dictionary, checking online for definitions of the terminologies. We hope to get more understanding with the process by doing more cloud projects on EC2 and generally on elastic load balancing. So as to enable us have background knowledge in the process and terminologies. Thank you so much. All right. This is actually the end of the project, and I can't just forget to thank my again. I've really thanked her so much. But in fact, anytime I'm sleeping, I woke up, I still think about her because she's been there. She's just like a mother. I don't know. My mentor, my teacher, my tutor, Dr. Mrs. Omotola. Please, anywhere you are watching this video, know that you've really impacted in us. With ECSL, the CyberSafe Foundation, those who choose um, cloud security as a career path are really grateful, and I hope on a very good day we'll see one-on-one for me to actually show my heartfelt appreciation to you. Thank you so much. Thanks to ECSL, thanks to CyberSafe Foundation, thanks to my confidence level, thanks to everyone, success seeker, thanks to everyone for the opportunity. Even my friends in cyber gears, I don't really know more you guys by name, but I'm sending my gratitude to you people as well. Thank you and remain blessed. See you guys in the next video. Thank you.